Hello everyone, this is Dr. Sunita Bulla. In this session, we are going to discuss about how to containerize Spring Boot application. Before going to discuss about to containerize Spring Boot application, we should learn two definitions. First definition is Docker Compose. Second definition is Docker Network. This is the folder I am going to share with you. In this folder, first file is a skill 9 commands. So this file having the material related to the two definitions. One is a Docker Compose. Second one is a Docker Network. First of all, what is a Docker Compose? We already know Docker file. So now in the last session we containerized the React application by using the Docker file. So first of all, by using the Docker file, we can able to run single container. Let's assume it is a Docker file. You have a Docker file. By using this Docker file, we can able to run only one container. So let's take our Spring Boot application. The Spring Boot application having the backend code and at the same time database. Now backend code is a Spring Boot code and database is a MySQL. So now there are two different technology. One is a Spring Boot project. Second one is a MySQL server. What MySQL database. Now here, if you want to run the Spring Boot application, we need to maintain the two containers, right? If you are using Docker file to start two containers at a time, we need to write a lengthy of the commands, like whatever Docker commands. So we need to write a lengthy command. Now instead of that, we are moving to Docker Compose. So now, so here Docker Compose also a text-based file. It is also a text-based file. At the same time, this Docker Compose is a tool. In this tool, we are going to define how to run the multiple containers. By using this Docker Compose, we are going to define how to run multiple containers by using single command. Let's say Spring Boot application. Spring Boot application having two containers. One is for the backend code. Second one is for the database. So now for that purpose, we need to create a multiple containers, two containers. Now here we are going to create two containers for this experiment. The three containers we can run by using the single command when you are using the Docker Compose. Okay. Instead of typing long lengthy commands, we are writing multiple containers running in the single document. That document is called Docker Compose. Okay, that is the purpose of the Docker Compose. Next, why we need to use this particular container? First of all, first benefit is it is easier to set up the multiple containers. For example, let's take our front end application. Not a front end application, full stack application. Let's consider full stack application. In this full stack application, having the Spring Boot as a backend, MySQL as a database, front end as a React as a front end, React as a front end. Now here, if you want to run this application, full stack application, we need to create one container for Spring Boot, one container for MySQL, one container for React application. So there are three containers. If you want to run the full stack application, we need to run three containers at a time. So this running three containers at a time by using the Docker file, it's not possible. That is the reason we are migrating to the Docker Compose. In the Docker file, it is possible, but we need to write a lengthy of the command. So now let's see the example. So if you are using Docker file instead of Docker Compose, Now here there are three commands. One is a docker run MySQL environment variables and username, password, MySQL username, password, path, and everything we need to give. And we need to run the Docker Spring Boot. We need to run the network also. Network we are going to discuss about the network. Now, Spring Boot and MySQL, these two technologies have to communicate each other to make it as a single application. Now here we need to maintain the network. For example, if when you run the Spring Boot application, what is going on? The Spring Boot application running on the 3306 like at 80804 port and MySQL 3306 port number. Now they are communicating each other by using the network. Now here also in the Docker also we need the network. Now here we need a network. We need to define the network connection also. Now if you want to run the Spring Boot application without using Docker Compose, we need to run three different containers to run an application. Now if you are using Docker Compose file, if you are using Docker Compose file, simply one command is Docker Compose up. When you type the Docker Compose up, here what happens? Now whatever containers you defined in the Docker file, everything will run. Now for example, take the front end database and back end, right? There are three containers. If you define three containers inside your Docker Compose file, when you type the command Docker Compose up, all three containers are automatically run. Next, now here we will declare everything is in a one file. Now in the Docker Compose is a text based file, and here everything we are going to declare in a one file. We are going to declare related to the containers, front and back end database containers information, environment variables like MySQL username and password, Spring Boot connection details and everything, port numbers, network details, volume details, and start stop, everything we will mention inside the single file. So that is the reason we are using the Docker Compose instead of the Docker file. Next one, network. Now if you are using the Docker file, we need to define each and every network. What is a front end network, what is a back end network, what is a database network, what is the database network, everything we need to mention inside the Docker file. Now if you are using Compose, it's automated already by default, and the template network details will come. So now this network is automated. Next one, a one command control all the things. We already discussed Docker Compose up. When you type the Docker Compose up, now it deals with the all the things starting the Docker Compose. Like for example, I mean, when you click on starting and when you type the Docker Compose up, it starts the all the containers. It starts the volume. It starts. Your database also. Now if you want to stop, if you want to delete all containers, for example, if you run the full stack application, so three containers automatically created, volume created, network created. If you want to delete everything, now simply type the command docker compose down. Docker compose down. So now what happened? So all whatever you created containers, everything is dropped. Next one, rebuild. If you want to run again, simply use the build. Okay. If you want to check the details, logs, how it is going to execute the Docker Compose up, when you type the Docker Compose up, how these commands and one by one how these are executing. Just type the Docker Compose log -f, then we can see the all the logs. Next one, environment specific configurations. Now here in this compose file, we will mention everything MySQL details and database details. Now here these are the These are the advantages we are using the Docker Compose. Now, when if you are using Docker Compose, we can run multi containers at a time, expressing everything declared in a single file. Network is automatic. Now it is a single command instead of lengthy command. Simply it's a single command, and environmentals are everything is auto setup. So now our come to our case. For example, if you want to run the e-commerce backend application, now here without Compose, if you are not using the Compose, what we have to do? We need to run the MySQL container separately. We need to run the SpringBoot application separately, and whatever network links, everything we need to write inside the Docker file. Okay. Now here, if you are using the Compose, everything we will write under the services. Docker Compose maintaining the services. In the services, whatever containers we will define everything in the Docker Compose. That compose is called, that file name is docker compose.yaml. That file name is docker compose.yaml. So now everything we will define inside the docker compose.yaml. In the docker compose.yaml, under the services, we will mention everything. Simply run the command docker compose up, everything is created. Docker compose down, automatically delete everything. Okay. Now next, this is about Docker Compose. We are going to see about Docker Compose, don't worry. First of all, next one, Docker Network. What is the Docker Network? We should know what is the Docker Network. Then only we can use this Docker Compose. First of all, Docker Network. The Docker Network is nothing but it's like a private LAN. Okay, here we are going to deploy full stack application. That full stack application going to execute in your container. So if you want to communicate with one container to another container, we need a network. If it is internet, we will use the LAN. LAN. If it is like a everything is happen in the internet, but here we are using Docker network internally using the private LAN. The private LAN is used to create this Docker file. Now here at this, it will define inside the Docker. Okay. Now all the containers are attached to the same network. For example, full stack application, front and back and database. Now all the containers are in the same network. They can communicate each other. Okay. Now first of all, in our C block, we have first floor, second floor, third floor lab. Each floor having individual LAN. So now if you are using IP address, now by using the IP address, we can connect any system network by you in the inside the first floor lab. If you want to use first floor lab IP address in the fed block first floor lab, it won't work. So similarly here, if you are deploying the full stack application, now here we have to use the same network for the all the containers. Now here they say Docker Compose file. Similarly, backend and MySQL, both we are using this Docker same network only. Here we are for this network declaration, we are not using any IP addresses. We are not using any IP addresses. So that is, we are using, instead of using IP addresses, we are using names, service names. Here network name, identify the network name is different. Why? Because when you running the containers, different containers will come. For example, I have printed a Docker image. If you run first time, one container will create. If you run the second time, it's another container will create. If you run the third time, another container will create. Like that, if you go to the IP address, different containers identification is very difficult. That is the reason we are using names instead of IP address in the Docker network. Okay. Now types of the networks. So types of the networks, there are two types of the networks, and the second one is for not this topic. but actually three networks. One is a bridge network. So now this is a bridge network. uh, this bridge net we are going to use bridge network in the system, in our systems, right? For example, bridge network is nothing but each container having its own IP address, and we can customize that IP address. They are communicate each other with the IP address. This is for local implementation. Whenever you created a container in your local system, by default bridge network is available. Host network, so host network is used to real-time environment. That real-time environment is nothing but, here we are going to use Linux, like mm, Linux environment. The host network is container is nothing but when you are working in the real-time environment, network stack, different stacks are created. That will is called host network. Overlay network. Next, overlay is nothing but it is for Docker orchestration. Okay, and now if you having the multiple containers, for example, RKL University having the different application, ERP, website, exam section, library. There are different applications. That applications are deployed in the Dockers. Those Dockers are deployed in a Kubernetes, like orchestration. That orchestration, that kind of environment, we will use the overlay, and each container working on different hosts and acting as a individual applications. Now there is no network. Actually, there are three different types of network: bridge network, host network, overlay network, and no network. So no network in the sense we cannot single container. It is a single container. We cannot communicate with the other containers. That is called no network. These are the types of networks. Next one, how to check the network. Okay, how to check the network. First of all, when you type the Docker network ls, it will show the list of networks. It will show list of networks. Then if you want to inspect, back end, if you want to inspect front end as a private or public net. Now here we are using the inspect command along with the network name. How would you know network name? Here Docker network ls. In the Docker networks ls we can see the list of networks. Now here type the command docker inspect, Docker network inspect by default command. That is the way we can inspect our networks. Any issues in the network we can inspect. We are working on the locally, so in the local system mostly there is no network inspect. If you are really working on the real time environment, any network related issues will go with the network inspect. Okay, now next, how to connect with the network. Okay. For example, if you want to create your own network, if you want to set your own LAN, in that LAN you want to deploy a full stack application. Then we have the commands, but we are not doing. But this information purpose. Instead of default networks, if you want to use your custom network, to create a network, command is docker network create mynet. Now, if you want to deploy front end, then docker run container one in the mynet. Okay, if you want to run the React application, and docker run React container in mynet. Like that, we will use this is the way we can run different containers in the same network. Okay, if you want to check the communication, how communication is going on, C1 or C2 both are communicating each other. Why? Because you deployed your C1 1 container 2 in the same network. Now here what we have to do, if you want to check the communication, we will use C1 ping C2. If it is executed, then both networks are communicated each other. So this is the overview of Docker network. Okay. In the Docker network, when Docker network will execute, how it's come to the picture. Okay, up to now we use the Docker file. So now there is no network concept, it is no isolation. So only single network, the single network is deploying and displaying output as a container. Now at present, how the network comes into the picture. Now when you run the Docker compose, now here this is the Docker compose.yaml file. The Docker compose.yaml file having the multiple containers. That example DB backend frontend. So now three containers. Now network, it comes into the picture. Bridge network, by default it follows the bridge network. Okay, now how to define the network. So for example, see here, this is the example of simple compose file. Now every this compose file starts with the services. Starts with the services. First service is the DB service database. Here we are going to define is the network. Network name is backend net. So I already told you network we will define using the name, not IP address. Okay. Now if you are not define anything, by default it will take. We no need to worry about that. Now next one, backend. Now backend code, network is backend and it's going to communicate with the front end. So now we need to specify that backend network, and next one we need to specify where it has to be communicated. Okay. Network front end. Front end is nothing but is a front end, and network builds are front end. Now front end not sending any communication with other, but front end fetching the details from the back end. Okay. Now front end only running the application, it fetching the details from the back end. That is the reason we are mentioning the back end, two network details, two network back end and front end. So now here in this database, now here this network going to send the details to the backend. So backend going to fetch the details here. So that way we are specifying here backend network. Now there are two networks. One is the front end network and backend network. Now let's see here. Here, first of all, in the network create by name, and compose automatically create the network. For example, first see the example Docker network. In this Docker network figure, so see a front end, back end, MySQL. So front end is running on the own container. So the container having Nginx server along with the React application. So this network, this front end is going to communicate with the back end. Back end networks. Then API calls. So here back end details. This back end going to send the information to the front end. The back end is going to send information the front end using the API calls. Right. Next, when coming to the database is running on one container. The database going to send the details to the backend application. So now by using the JDBC or Hibernate, whatever your connection details, JDBC or Hibernate, now it's going to send information to the backend network. Now detailed explanation I mentioned inside the notepad. So all of you find the information. Now this is about the figure. Next. So Docker network flow. How Docker network will working? Front end application going to fetch information for the backend with the help of API calls. Database sending the information to the backend, and at the same by using the communication protocol MySQL, and front end also, front end database and backend. This is the network flow. It is called a bridge network. By default network is a bridge network until unless you are mentioning the custom network. By default network is bridge network. So comes to our application. Here containerize backend application without volume. First of all, no need to worry about the volume, leave it about the volume. So we are going to containerize application, backend application. So now keep it in your mind the word without volume. Okay, right? What is the difference between with volume and without volume? We will discuss later. First of all, backend application. We need backend application. So this is a folder I am going to share with you and share with you. First of all, this is a backend application. Now here we are going to execute multiple commands. So that is the reason I am opening this backend application with a VS Code instead of Eclipse or STS tool. I am going to open this backend application with the VS Code. Why? Because our VS Code is already our VS Code is already configured with the Docker Hub. Open folder, e-commerce backend. I am going to open e-commerce backend here. Now see here, this is the e-commerce backend. E-commerce backend, right? Now first of all, first condition in a Docker backend application, when you are working with the when you are working with the Git CI/CD, we used Spring Boot application. Outcome is jar file. Okay. So whatever your pom.xml, the pom.xml, uh, when you run the pom.xml, it generated the jar file, right? Next, when you are using Jenkins, so right here we are using the Jenkins. When we are using the Jenkins, the Spring Boot application, we use the packaging is a var file. Packaging is var file. Now next, now we are going to use the Docker. In the Docker, same Spring Boot application. So now same Spring Boot application, we are going with the jar file. So I request you all the faculty, don't use whatever project we used for Jenkins, don't use that project. Okay. Now whatever I am sharing, all of you take this project only. Don't use Jenkins project. If you are using the Jenkins project, and why? Because we have a e-commerce project. Many e-commerce projects are in our directory. So that is the reason I am same. I shared that. I mean I changed name is Docker e-commerce database the backend, right? All of you take this folder, and when you are taking this folder, so see here, first of all check is there any .git folder there. Now go to the hidden files view, and inside the view hidden items, click on the hidden items. For me not showing, I deleted. For if you have a found .git folder, simply delete the .git folder. Okay, .git folder. Why? Because this experiment, okay, for next experiments it should, when you are pushing into the GitHub, it gives the error. So if it is there .git file, then simply remove that .git file. Okay. Now, so this is the folder we are taking. Now see here, first of all, when you are taking the project, we should check the pom.xml. Now here that pom.xml going to packaging the jar file. So now packaging is a jar file. Package jar file name is e-commerce. When you run this application, it is going to generate the jar file. So now package.json, and at the same time, now this is the things we should remember. Okay, when you are working with the Docker, Spring Boot application is a jar file. Okay. Now next, everything is okay. This is the Spring Boot project. Terminal, command prompt. Now see here, this is the project I am going to take. First of all, before running this one, open the Docker desktop. Don't forget to open the Docker desktop. When you're working on a Docker desktop, don't forget to open the Docker desktop. At the same time, don't forget to log into your Docker hub. Why? Because we don't know if it is asking the details related to the, Docker desktop, asking the login. So that is the reason we need to open the Docker uh, hub also. So now sign into Docker hub. My having my Docker and Docker front end, two repositories I have. So next one. Now this is the desktop. My account already logged in the Docker desktop. Okay, my account already logged in the Docker desktop. Now see here, so this is the application. I'm going to use this backend application, right? Before going to run this one, just go to the main and resources, application properties. Here check your database details. My database details are e-commerce is a database, and at the same time uh, username is root, password is root. Okay, if you have another credential, simply change the credentials. At the same time, change the port number 8081. Why? Because when you run your application, here Spring Boot application by default 8080 port number will execute. Now that is the reason in our systems 8080 allocated for the Jenkins already reserved. So that is the reason all of you use the port number is 8081. Now these are the details: server port number, username and password, and database we should check. Okay, two files: form.xml file, application.properties file. Now let's come to the experiment. Next, what first step what we have to do? We need to create a Docker file. So we already discussed we are going to create Docker Compose. But why Docker file? First of all, Docker, if you have a Docker file, then only we will create the Docker Compose. Docker file is mandatory file to execute, convert your project into the Docker image. Okay, front end folder, you should write the Docker file. Back end folder, you should write the Docker file. If you have a Docker file, then only uh, then only we will execute the multiple containers. Okay. Now, Docker file. First, we need to create a Docker file. In the where we need to create in the root folder where the pom.xml located. Here we need to create file. File name is Docker file. So now in this Docker file, we will write the uh, Docker commands related to the whatever we're going to execute. Now I am going to share this folder file with you, Docker file. Here let me explain this file. So now a Docker file what I am going to create. See here, this is a we are using this image, base image, Eclipse image we are using. Now next one, working directories app, form.xml we already know. Then here we are going, first of all we need to create a jar file. we need to create a jar file, right? The jar file only going to execute. Now that is the reason we are going to mount our target folder. The connect to the target folder. Then after the target folder, execute the command clean install package. Maven commands we are going to execute. The target folder we are we are specifying with the Maven. Then after that we are going to clean install package. We are going to generate the jar file. Then after that, after creating the jar file, deployment purpose, okay, running purpose, what we are doing, we are running but not deploying any application, building and jar file. So now same, then we are same for running purpose. We are using the same JRE server, next work directory, and target find the target folder where the build location created. Take the jar file, app targets that start jar file, and this is the jar file. And next one, whatever your environment word will exposing in the 8081 port. 8081 port and execute your jar file. Okay, whatever your jar file, that renaming it as a app.jar file. Okay, that app.jar file, this jar file we are going to execute by using the java -jar app.jar. So now then our backend application is going to execute. If you want to work with the WAR file, so it's not suitable for the Windows operating system. If you want to work with the WAR file, simply what we have to go with the Linux operating system. Now close, copy paste. Now build. So this is a Docker file. This Docker file we are mentioning here. Next one. Next, what is our target file? This is the file for to create converting project into Docker image for Spring Boot project, not for backend. Okay, this is the Docker file especially for our Spring Boot application. Okay, right. Now next, for running multiple containers. For running multiple containers, we need to create one file. File name is Docker Compose. This Docker Compose where we need to create. First, depending on the project. Okay, for example, if you have only backend, no front end, backend with the database, we need to create inside the root. If you have front end backend, we need to create outside the front end and back end. First of all, we are using the back end. Let's see about the back end. In this back end, if you are running only back end, here we are going to create a Docker Compose file inside the root directory, in where you created inside the pom.xml, not inside, in the root location. Now here in this root location, we are going to create a Docker Compose, small letter, Docker hyphen compose dot aml file. Docker compose, it is a red color Docker symbol only, but it is placed red color. Okay, now here there are two files. One is a Docker file, second one is a Docker compose. Docker compose we are going to create here. So now in the Docker compose, what we need to mention, here, now first of all, this is the file without volume. We are saying here, db, under the, I already told you, under the services we are going to create containers. First one, db container, for first container for db. Now db image name, container image name is MySQL 8, container name is e-commerce db, environment is MySQL. How to connect MySQL? Root password is root, database is database. If you want to check health checkups, like if it is working or corrupted, we are go with the health checks. Next one, backend. So now backend we are going to build. Okay, first build. Container name is e-commerce backend. So now it's depending on the DB connection, establishing the connection and a condition, and environment is server port number is one, data URL and username, password. These are the environment variables, and port number where it is going to this one like a 80 and 81 is a port number. So this is the Docker Compose file. All of you copy this file and paste into Docker Compose. Now in the Docker Compose, we are mentioning two containers. One is a MySQL container. Second one is a e-commerce backend container. Two containers we are using, MySQL and Docker backend. When you run this particular compose file, here two containers are going to create two images. Two base images are going to create at the same time running also. Now in a previously we are used the Docker file. Now to see the output we need to type the two commands. One is the Docker build, second one is the Docker run. Now here we no need to type two commands, only single command. That command is Docker compose up. When you type the Docker compose up, these two images automatically created. We no need to worry about that. So now first see the commands. Now first for created Docker compose and Docker file. Two files are created. Now let's see the commands. Now first we need to type the command docker compose up -d build. Okay, this is the command we are using. So copy this command. This command we are going to run the command. So see a Docker desktop. I don't have any images. I deleted all the images. I don't have any images. When I run this command in my images containers, the two images will come. So now here Docker compose build up -d. First of all, it's creating DB container, database container. DB container is nothing but it's going to create one MySQL server inside the container. So my system also having workbench like MySQL workbench. So we no need to worry. If you don't have a MySQL, no issue, leave it. Why? Because we are going to create one container. I mean the container having database software. If you have a MySQL in your local system or not, no need to worry about that. It can be create the container, database container. We are using this container for our project purpose. So we no need to worry about this MySQL, our local workbench and everything. Leave it about this one. Just work on the container. So it's going to create two containers. It takes a little bit time. Uh, all of you ensure your internet connection is good or not, because it's going to create two containers. A database container. So now it's created. Database container created. DB pull, image created, and see here backend image created, network created, a container created, DB container created, DB backend created. Okay, four things created. Single command Docker Compose up. By using the single command, four things. One is a image, backend image created, and network also created, and a database container created, and e-commerce container, backend container created. Okay. Now see here, two images. One is a Docker backend, second one is a MySQL. Two images created. These images all already on running stage. Go to the containers, e-commerce container created. Okay, e-commerce container created. So see here, everything is created. Now if you want to execute, how to check the output? Okay, if you want to check the logs, then type this command. If you come out, then if you want to check the logs, copy paste whatever logs. Now see here, if you want to check the backend logs, uh, type the command. This is the command. We can check the all the logs. Okay, these are the logs created, going to run. Okay, if you come out of this one, press Ctrl C. Now if you want to check the logs of uh, container, then we use this name. If you want to check the logs of backend, use that backend, e-commerce backend name. Okay, now first of all, how to check the output? If you want to check the output, now go to the Docker container is created. We already know it's not a front end, not reflecting on the port number. We cannot see the port number here. Now if you want to see the output, go to the browser, type localhost colon 8081. It is a product. There is no product. Okay, there is no products up to in the database. If you want to check the backend, we need to type the command localhost colon 8080 API products. Now what we have to do? Mm, Now we need to execute queries inside the database. We need to execute all the queries inside the database. First, where we need to execute the queries? Not in your system. Okay, now what we have to do? We created here we created one container name is e-commerce db container. This container, this application, whatever your application going to use this e-commerce db container. So that is the reason we should open this e-commerce db container. Here we need to execute all the queries. How to open this e-commerce db container? Now go to the document. Now first of all check. So now this is the command. This is the command we need to access the e-commerce DB container. Docker execute it e-commerce DB. MySQL username is uroot, password is proot. Okay. Now all of you copy this command. Now paste here. We can open the e-commerce DB container. The container having the MySQL software, MySQL server. See here when you type in this command, the command open the MySQL. Now execute. First of all, first command show DBs, show databases. First command is show databases. It will show e-commerce database. When you run the project, e-commerce database by default it created. Now next command, use e-commerce. So you so e-commerce change. Next one, show tables. How many tables are created? By default project, there are two tables. One is a product and second one is a user. Now next, add the products inside the add products inside the uh, MySQL container. Okay, copy paste all the commands at a time. Okay, now executed. All queries are executed. If you want to check the table, type command select star from products. So now select star from products. Okay, semicolon. Okay, all products are written. Now come to the browser, refresh this one. We can able to see all the database. Now here, all of you remember one point, we are not using local system MySQL. We are using MySQL container. The container is created by the Docker Compose then file. Okay. Now, if you want to test with your friend end, now it's okay. Now, if you want to test with your friend end, now last experiment, what is the last experiment? Skill practical 4. Now here we run the e-commerce front end application, right? Now open this, run this one, we can see output. You open one more VS Code. Here open front end, file, new folder. E-commerce front end. Now here that e-commerce front end. First of all, the whatever your project, the project is running on 8081 port number. We should change 8081 port number in all the API calls. Okay, 8081. Now run this one. Run this project, front end project. I'm running the front end for output effectiveness purpose. Create a Docker image. Then create Docker. Run the Docker image. So now we are using front end, right? Here we are using back end. It's back end working properly. Now let's check with the front end back end how they are communicating each other. Both are using the same bridge network, right? So same container they are using. By default it is a bridge network. We no need to specify any network. By default it is a bridge network. And image like there are two image. One more image front end image also going to create. Now npm run build. Now here container created. See here image created, e-commerce front end created. Now run this image by using run command. This experiment we already did, but I deleted. That's why I'm doing again. So whatever e-commerce front end, keep it in your Docker desktop. Run when you are working with the backend. Now here in the Docker desktop, go to the containers. The front end is working on 507380 port number. This is the front end, and this front end we already mentioned the API calls. Click on sign up. Username some ex. Email is ex at gmail.com and password is ex. Okay, click on sign up. Super. See here, It's working. Sign up successful. Okay, login with EX. And when you click on the mobiles, it fetching the details from the backend. Now if you want to check backend, select star from users. What are the tables here? Two tables to users, right? Select star from users. Now one user executed. Now front and back end communicating each other. So this is the way we are going to use, containerize backend application uh, using the Docker. So next class we are going to discuss about same application with the volume. Okay, we will discuss what is the volume and everything in the next session. Now all of you just keep it in your mind. We are containerized our application without volume. Thank you everyone.